start recording. Hey, welcome to day 2. Okay, so today we're actually going to try some programming. So in your lab, if you've got it, if you started it, you would have already installed Python and idle to use that, or you could use now I should mention, for those of you who do have some experience with programming, I use idle a lot in this class to do the actual programming in Python for the first half of the semester, because it comes pre-installed with Python, meaning that's one less program for everybody to install. But can you use something like VS Code or Spider? Totally. I don't care what you use, as long as it works for you. So you can use whatever application you want to do your programming in. If, however, you are starting this for the first time, I recommend working in idle simply because it's already there and it's very straightforward to work with. The other place that you will be working in Python on is in your textbook. And that's what we'll be doing today. This requires no installation on your part. It just requires a web browser, which is great because a lot of you could have a Chromebook, but although I see a lot of Macs today, so that seems to be the very popular option. Okay. So let's see. So if you haven't already, we can click over here to get to Runestone Academy. And if you haven't signed up for the course already, now is the time to do so, right? And you would want to do with the following, right? Put in whatever your username is. So Prof. Rosen for me, right? If you haven't registered yet, right? First name, last name, as it appears on Canvas. And if you don't do that, then make sure at the very least you put in your TU email as your email, which would be for me, tug85861@temple.edu. Okay, not sure, and if you do that accidentally, it's okay. You can always make another account. It's no problem. But if one of these two things match, either the Canvas or the email, then the import program I'll be running periodically to import your grades will run. Also, you will not receive any, you're not going to receive any grades in this part until until I run the grader. I have to actually manually run the grade. It will tell you what your grade should be, though. That's what the textbook will do. This is not something to worry about. It's because worst case scenario, it does track like, hey, this is what this student clicked on went to this page. So I can so if there's an inconsistency, I can totally see what you did to make sure that you get the appropriate grade. Okay. So anyway, figure out your password, fall 2022 Rosen, and that will direct you to the correct, sub site of this textbook so that you can be registered for my class. Okay. So once you do that, right, you'll be able to access the course, which will look something like this. So again, the kind of idea here is that I've got some over here. You'll want to periodically check, and I'm going to make sure that the front page of each module has the correct dates, because I've just been a hectic week. I haven't had time to fully work on the Canvas site other than to get the most important information up and running. But here are the due dates for like when you should have these things done. So reading chapter 1, I wanted that due today, but these are soft deadlines. They are soft as a cute animal's fluffy fur, right? It means that it means that this is what you should have done by this point. You will not be penalized for having it done later, no matter what time later is, right? You could have this done at the end of the semester and you'll still get full credit. These are very soft deadlines, okay? Unlike other deadlines, like with the assignments and the exams, which have fairly firm and hard deadlines, okay? So I don't want you to get stressed out about this. If also that you feel like you are receiving too much work in this class, please let me know. Like it's very hard for me sometimes to remember, what the difficulty were when I started programming. And so to accurately kind of assess the time that it will take to do an assignment. So if it's taking way too much time, please let me know. And the easiest, a lot of times the easiest fix for me is just simply say, okay, I will just review that problem in class so that nobody has to worry about that problem. So please let me know if things are, get too time consuming. Because I am aware that you have other classes. Unfortunately. So, all right. So so anyway, what we're going to do today is, once you've logged in, is scroll down all the way to the bottom of this book. Right? And this applies to the people who are at home on Zoom, or being, either because they can't get in or they're social distancing, right? And kudos to the people who sent me emails saying, hey, I'm not feeling so great today, I'm going to stay home via Zoom. That's the right decision to make. That's what I want to see. Okay. So a preview so we're going to work on project 1, which is a preview of the end goal, which is going to show us basically what this textbook can do and kind of where kind of directions we should be able to go in this course. So we click on it and it brings us to this page. So there's a lot of cool things about computer science that we can do, and the textbook author has his own words about how he finds it exciting. And one thing I really do I do love about his statement is he's saying you would not expect to sit down at a piano for the first time and play Beethoven's Piano Sonata number 32, opus 111 in C minor you have to work up to that. And that's what you've got to do. This is a course where you're practicing. So if it does not immediately click for you, does not immediately work, don't get frustrated, with yourself. Because it's all, anytime you're starting anything skill-based, for the first time, it's going to be rough, So, what we're going to do is in this assignment was that we're going to, or this in-class assignment, we're going to see what kind of things we can do. I'm not expecting you to understand any of the code we're doing. There's a lot of complex code in here, in fact. I don't really care about you understanding it. What we're going to do is run it and use it, which is different than understanding. To understand is to fully appreciate it, but I think we can get a decent appreciation by just being able to use it. So one thing I love about this is the ability to run the code in here. And not only that, it doesn't just handle text input and output, it handles image processing. So here's a function they wrote, a lot of code. Some of it's English, right? Import image, right? You kind of understand what that those are words. Those are readable words, right? Whereas def is like, huh? What's a def? I mean, it's short for define or define function, but honestly, it's well beyond what we need. But we understand there's some stuff going on. Also, there's some funky stuff going on in the white space. What's that white space? What is white space? It is that blank space we can't see, right? It's your spaces, your tabs, your you hitting the enter key. White space is important in Python. For right now, you don't have to worry about it for your homework assignments, but as we get to make more complicated statements, we'll be using white space. For those of you who are coming from a different language, white space fulfills the role that curly braces and other kind of indicators typically do, because your code should be indented properly. And so Python just simply assumes you're going to indent your code properly, and so you don't have to waste keystrokes with putting in curly braces and the like. So there's other things here for row and range, height and stuff. But honestly, again, we don't need to really understand this stuff. What we do need to know is, how do we run this? Well, obviously download would give you a copy of it. And load history, this is what I love. If I make a change to this, like if I were to import a separate function, which is just an easy enough change, and run it, it saves a snapshot in my personal directory for me to use. And it says when it was. So I'm going to just revert. Well, I can't because it is running, believe it or not. That piece of code is running on a picture, and we can see the results as it's going through. So what this code does, if you haven't been able to kind of figure it out, is that what it's doing is that it's converting this picture into black and white, which is different than grayscale, right? Grayscale is shades of gray. No, this is literally black and white picture as opposed to grayscale. So it's one of those pedantic differences, I know, but I'm trying to be exact here. So, and what it's doing is that it's going pixel by pixel to do that, which of course I've now introduced another term that must be defined. What is a pixel? It's short for picture element. So if you get really nice and close to your computer, and it's really hard on the new Macs, by the way, because they pack those things so close together in the new Macs. But if you've got a screen with about a 1080p resolution, you should be able to go get forward to your screen and look, and you can see that that your pictures are actually made up of little tiny squares. They are any picture that you see on the computer is made up of like little tiny squares that are each have an individual that are each receiving an individual code to tell them what combination of colors. Each of those pixels have something called a subpixel in them, which is way more than you need to know, which says that this is the amount of red, green, and blue of light that we want to emit, and then through doing that, we can make the appropriate amount, the appropriate color. All right. So obviously, the people who wrote this textbook, they were at Luther College, but there we go. And now it's converted the picture to black and white. So what it does, so this is what we call the source code. The source code is the thing that you run and it executes. Basically, it's the code that performs something. So when you hear somebody talking about source code, they're generally referring to actually the code that works. This is in contrast with some language which are called compiled code, where basically where the code gets translated into extremely efficient machine readable only instructions that humans cannot read because it's gibberish to humans. Okay. Now, what is this doing? It takes the width and height of the image over here. And this over here says basically, we're going to go through every single pixel. Let me go ahead and make it bigger for the people in the back. Go through every single pixel and get that pixel. We're going to figure out how much red, how much green, and how much blue is in that individual picture. Because when you're working with light, which is how we work with color here, color, by the way, is extremely hard because you have different models of color. I am going on way too many asides. So anyway, what we figure out is that if the average value is bigger than 127, then we make it one color, otherwise we make it another color. So if it's more than 127, we make it all white, otherwise it's an all black pixel. That's what I mean by color is complicated. It's hard for me to remember, wait, is 0 white or is 255 black? Can't remember. Can't remember which one is which, because again, we have different models for color, additive and subtractive, and if you've been working with markers and stuff, you're used to one model, and then light uses a completely different model. It's weird. But anyway, all it does is that then it just updates that pixel to change it, and then draws it. So this code over here at the end, it gets ran when we do this process 11, and then we call it on image. So specifically what's going on over here is that over here we are defining a new command. A lot of this that goes on in Python is about defining functions. What does that mean? Well, Python is a language, and essentially when we define a function, we are creating a new verb for this language. It's a very boringly named verb, process 11, but it is a new verb. And so now we, at the bottom, once we've defined it, we use it. And the technical term is we invoke it, which makes it sound like wizards, but we invoke that and then it runs. So we've got a bunch of different functions over here. We've got 1, 2, 3, 4, all the way up to 10. Let's see, can I run these? Or is this just simply defining it? I believe it's just simply defining it. So we've got these functions. We've got 10 separate functions that have been defined, okay? And I also have 2 pictures here, the yawning squirrel and the Luther Bell picture, okay? What we're going to do is that we are going to experiment and figure out which process basically does what. So for instance, over here, we are running, it's saying, hey, let's load up the image of the yawning squirrel, right? That's the file name that it's got in here, yawningsquirrel.jpg. If I wanted, so notice that it's yawning_squirrel.jpg. We wanted Luther Bell pick. We'd want to do capital L Luther, capital B Bell, capital P, exactly as written. So the easiest way to do that is just simply copy paste it. If you want to switch the picture, but honestly, I like squirrels better. And then we take our original and then we run it through the process here, this is calling process 10. And it works exactly the obvious way you think it would. If you wanted to run process 1, you do that. If you wanted to run process 2, you do that. But let's look at process 10. Let's see how this works. Also, don't accidentally delete it, but anyway, run it. Let's go ahead and run process 10. And it will load up, and oh God, it's demonic. Okay. So anyway, we've got all these different kinds of processes that go on. So for instance, running process 1 instead does this to the picture. So what I want you to, so your goal for today, for this first part, is to mix and match. Basically, this is a drag and drop over here. So basically, we would drag whatever we thought it is. It's not Leiden's image. I'm just kind of showing you, right? Over here. Okay. So we figure, so basically you want to call each of these functions and figure out what it is. There is only one pitfall, and that is this. Process 5, all of them say, hey, give me an image, and I'm going to do something to that image. Process 5 says, give me an image and a number. I'm going to do something to that image. So you got to do two things. How do you do two things? Imitate it. Give it a number, image. So here we'd pass in original and maybe a number like 5. If we want to do process 5 or maybe 2, you can do whatever number you want. I suggest something small. Okay. So notice how it's taking in 2 things for process 5, and process 6 takes in 3 things. That's the only pitfall there is. If you're having trouble with that part, please let me know, and I'll be happy to come over to you and help you correct that. But the main part is using this to run this. Now, remember, if you completely muck this up beyond all recognition, you can always rewind by just by clicking load history and dragging this bar. And it will give you and you'll be able to revert to the original code. So it automatically saves every version you run for you, which is super useful because, I mean, there's a number of times I've accidentally messed stuff up while I was programming is, well, if I had a nickel for every time I did it, I'd be a rich man. So, so anyway, so that is our first part for that. Once you're finished with that, we will move to the next part where we learn about combining these effects. So go ahead and get started. Feel free to talk and work with the people around you and next to you, please. This is a collaborative effort. Your grade on this is based on completion, by the way, but it will tell you whether or not you got it right or wrong, and there's not any penalty for getting it wrong, so you can feel free to keep, trying and trying again. And for the people in Zoom, please just try your best to work on it. I'm going to go ahead and pause the recording. Told you about. So let me resume the sharing. So how are people doing on this mix and matching part? How are people doing on that? People still working on it? Few people. All right. So I'm going to go ahead and go over it though, since the vast majority are done. So we're going to go through this 1 through 10. Okay. And again, I'm super zoomed in. Just bear with me, just rapidly scrolling in because the people in the back otherwise will have to deal with like really small text sizes. So, all right. So here I'm going to so again, here what I'm going to do is do process 1, run it. And this is our original image of the yawning squirrel. And now we run this and we see that we get well, let's see, we get, it's much more darkened. So vignette effect, dark corners, yeah, it seems about right. I'll drop it there for right now until I see something better. Because actually I don't have the answers memorized for this. Go to 2. Ooh, what's that one doing? That is like a weird pixelation effect. Maybe that's the Claridon. Darker darks and lighter lights. Let's see. Where's that part 1? Let's move on to part 3. Oh, that one's easy. Grayscale. Wait, did I hit 3? Yes, I did. Part 3. Part 3 is grayscale. Let's check our answer so far. Okay, at least I got that 1 and 3 correct. Part 2 I haven't done. So I'll move back onto that because that was weird. So 4. Run. That rotates at 90 degrees. So 4 rotated 90 degrees. Okay, 5, image and number. So we got to take in 2 arguments here. So we are taking in the original picture. Then I add a comma just like it had down below here. And then I got to add in some kind of number. So I'm going to give it 3. Okay, argument 3, but oh, right, I didn't change it to process 5. So give me an error saying, hey, you give me 2 arguments when I was expecting 1. So over here, you see that I basically rotated it 3 times. So here I can do that. If I did this 1, we would see, hey, it made 1 turn. So process 5, good bet that basically what it does is that it rotates in multiples of 90 degrees. Process 6 also takes, if I remember correctly, now takes in 2. So I'm going to do 2 and 2 because I remember what this one is. Fairly straightforward because it's the only possible option for it. We take our picture and it gets bigger. 2 and 2, which is enlarges in the X and Y direction. So if I change this to be 1 and 2, by the way, we'd get a very different image where one side would be, it'd be a bit more widened or heightened. In this case, very skinny screaming squirrel. So 1. So here. Shoot. All right, I have to zoom out for a second to get them all in. How annoying. 6. Are you serious? Okay. Yeah. Okay, there we go. 6, boom. Okay, sorry about that. Okay, now we'll see 7. 7, we take in the original. Okay, and that made it very black and white. So converts only to black and, so this will converts only to high contrast, black and white only. So that's 7. Black and white only. Okay. 8. Oh. Okay. So 8 gives us, let's see, that is kind of interesting. What is it giving me? So we've got this darker, but now it's lighter over here. So I would say it lightens the image, number 8. That's my guess. Okay. 9. We can go through 9 and we can go, hey, run the image and let's see what we get. That looks like a darkening. And 10, we saw that made it demonic. But specifically from our choices left, it means that it's only black, white, red, green, and blue based on I guess what the most dominant color is. So that checking those, which meant that the number 2 was the Clarendon, the darker's darkers and the light's light, which is what I believe what I initially suggested, but wasn't like 100% sure of. Because again, I haven't memorized these. Last time I did this was like entire full semester ago in spring. So yeah, the darker's darkers and the lighter's light. Okay, and check me. All right, you're correct. Great. Okay, now it's our turn to combine these various things together. So the idea here is that with functions, you can take the input from, you can take what you get from one function and pass it to another function. So here it's saying, hey, process 1 calls process 4 my image, and that's going to combine the effects of process 1 and process 4. Now, specifically what it's doing over here, as we'll learn in the upcoming weeks, order of operation rules in of mathematics apply in computer science. In fact, even more maddeningly, there's a few other order of operation rules, but they're all order of operation rules that you will have intuited, like what happens when there's a less than, like for instance, if you were to simplify 7 plus 2 is greater than or equal to 3 minus 2. You know, to do the comparison after you've done all the addition and subtraction, right? Any of the rules that you'd be learning are pretty much stuff that you will already know. Do you know order of operations for mathematics? You know your order of operations for computers, which means you know that things inside the parentheses get handled first. So this would be 4 and then 1. Here we're going to do 1, then we're going to do 4, but hey, that's fine. This is all about combining these. So first, this will apply the process of step 1 to it, and then it will do step 4 to that, basically combining the effects. And so now we get an effect that is slightly, what was process 1? Darkened? No, vignette effect, right? Dark corners, right? And then it rotated it. But there's like nothing stopping me from like doing this, where I can say, hey, process that, process that. What happens if I run process 1 on it twice? Guess the corner's really dark, So there's all sorts of effects that we can do on this. So if I wanted to add a third step, I would do something like this, by the way. I'd kind of like look at what's going on over here, and I'd kind of put in the code in the middle. Like, for instance, okay, so we had step 1 and then we have final. So it makes sense to put a step 2 is equal to, and then step 2, because it doesn't have a space, equals, and then whatever I'd want to do if I wanted to add another one. And then step 3, the same way, right? So for this one is the chance for you to get creative with this, okay? And to have some fun with this. Once you're done with these, answer the questions below, and here's how you get full credit. You have to interact with everything in here, so you got to answer all these survey questions, okay? And then you want to also make sure you basically hit anything that says save and run. So, and then it should give you all the all that thing completed. And if it doesn't and you're having issues with it, don't worry, I'll fix it later. So, okay. So go ahead and take the opportunity to work on this and come up with something creative. And if you run into any difficulty, again, let me know. Resume recording. All right, if you're stuck at 9 out of 10, by the way, it's because I messed up and checked. Basically, you need to interact with everything on the page. And one of the things starts automatically minimized, which is this, which has the code for all of your, it's like 200 lines of code, 300, I don't know. It's all the lines of code for all of the processes. So yeah, 300 lines. And just interact with it. So to interact with it, it starts out like this. You want to hit show code and then save and run. And that's where you're missing 9 out, that should bring your 9 out of 10 to 10 out of 10. Okay, that's my bad, I think. So, or the textbooks, but I'll take the blame. I can do that. So otherwise, I'll give you a bit longer to work on this. And then I'll talk about other things we will be planning on doing this semester. All right. Okay, so now, is everybody got into the ending point for this? So hopefully people have gotten to the ending point for this. If you haven't, I'll be happy to help you after this. So let's just talk about a couple things that we'll be doing throughout the semester, and the progress of stuff. So once we've kind of got the idea of how we, run code and execute code, which is the purpose of our lab, to basically create a hello world exercise. Hello world is essentially just the first thing you do when you boot up a new programming language to confirm, hey, it runs, basically. And that's what we're doing with your first lab assignment. We're just doing a bit more of a interesting variation, looking for a good historian. If you are still stumped on it, on a historical computing figure, may I recommend Rear Admiral Grace Hopper. Her history is a bit crazy. Navy Rear Admiral, first to devise from this theory of machine-independent light programming languages, the Flowmatic programming language, which was later extended to COBOL, the early high-level language, has a PhD in mathematics before she joined the Navy. She is amazing. So, so it's definitely someone to know about. But now once we basically figure out how to execute these things, the next thing we're going to work on is basically learning to use Python as an extremely powerful calculator. And this is good because if you're like taking physics or chemistry, once you get comfortable enough with Python, you will actually be able to use this to assist you in working in like solving equations and that kind of stuff. In fact, there are some, I don't know if Temple does it, but I know some universities, they have like two versions of physics: classical, where you solve everything on paper, and modern, where you are expected to use some programming to solve it. And Python can definitely help there. But we'll be learning about how do we basically turn this thing into a very powerful calculator, how we do operations, how we can create variables, and the importance of the equality operator. We'll go into a bit about debugging and how to import modules. So importing, as you saw at the beginning, we had this import image statement at the beginning of this exercise. And that basically said, hey, please load up the image library because I plan on interacting with images. We don't import everything because there's a lot of Python code and not every program needs all the code inside of it. Once we get the basics done, I plan on working on the Turtle programming language. Oh, sorry, not the programming language, the Turtle programming paradigm to teach you how to work with for loops. And basically, that's kind of our first step of doing repetition and automating stuff, because having to enter in everything and then copy paste it gets really annoying. So for loops allow us to do those things, and Turtles actually allows us to use a simple graphical paradigm to visualize what we're doing. We will probably do our first exam around week 4 or 5. I will let you know as soon as this is week 1. So I'll let you know around week 4 or 5, what more definite date. You will have at least a 1 week's notice for an exam, at least. And generally I provide practice questions. So, and again, the first exam will be fairly low stakes. I will plan on setting because this will be the first time I've done this 2-stage examination. I'm planning on setting the group portion to be worth 40% and the solo portion worth 60%. So assuming basically all of you are able to cobble together right answers, that's basically 40% guaranteed there. Really good addition to your grade. We'll be learning more about like kind of the tools that you have to create different structures and store data in here. And eventually I'll be going off the textbook for a bit and talking about 2 of my really, I guess, pet items, which are Monte Carlo approximations, which sound a lot harder than they are. They sound way more fancy, but what that means is that if you don't know the statistics or something, simply like a game, simply run that game, watch the outcomes, and see how often it comes up in your favor. So we'll be using that in specific, and I like doing that and kind of looking at using programs to figure out are certain games scams. That they present them as statistically, oh, you've got even odds of winning, but in reality, it's very much weighted in favor of somebody else. The other thing I like to introduce are regular expressions, which are pretty good over here. But I plan on doing a lot of interesting exercises throughout the way. Unfortunately, the first homework assignments will be fairly make work, just like, oh, do this boring mathematical thing, or solve or make your computer jump through this hoop. Not really exciting stuff because the more exciting stuff does require a bit of stuff. But eventually we'll be doing things like making translators, translation, basically making a basic text-based game, a dice rolling game. So things like that. But overall for today, this is all I have. The first week isn't too intense, but please keep up with the assignments. Again, I plan on going through this weekend and hammering in deadlines and due dates for pretty much everything. My last note is that if you do have some weird accommodation that you'll need for the final, please let me know the sooner rather than later. Again, I know that's months away, but the sooner you let me know, the later I'll be able to do that. So I'll be here. There's 20 minutes left. If you want to demo in that time or have questions, I'll be here.